Hello guys, welcome back to the Math Club. This is Paul Ayok, your mathematics instructor. In my previous video, I handled a question in mathematics that has to do with radical equation. And I demonstrated how radical equations could be handled easily without any difficulty. Today, I still have on the board a question that has to do with radical equation. But at this time around, it is a nested radical, which is a radical found inside another radical. So I am emphasizing on questions concerning radicals because I know it always poses a problem to students. Students always find difficulty handling questions that have to do with radicals. So on my board today is a Harvard University entrance examination in mathematics, and it is a question that is connected to nested radicals. So join me and let's walk through this question and see how nested radicals could be handled. Okay, if you look at the board, we are given that x equal to the root of 7 plus 4 root 3. They say find the value of x plus 1 all over x. Now, the temptation that most students we want to involve in would be to square both sides. Squaring both sides to eliminate this square root will automatically lead to a situation of so many radicals and a very long method of handling this problem. Given that this is a competitive examination question, it is but normal for you to apply methods that are shorter and easily understood. So I will actually proceed by saying that if you look at the question very well, you will discover that this expression inside our radical is obtained from squaring 2 plus root 3, all that squared. So this expression under our radical 7 plus 4 root 3 is obtained from this expansion. So if I expand this bracket, what do I have? I will have, like I said in my previous video, to expand such a bracket, you square this term, which will give you 4. You take this term multiplied by this other term, which will give us 2 root 3. And then multiply the result by 2 again, so it will give us 4 root 3. Then you also square this term. When we square this term, we have 3. So you see that in essence, 2 plus root 3, all that squared, is actually 3 plus 4. This means 7 plus 4 root 3. So if you look at it clearly, you discover that actually, when we square 2 plus root 3, it gives us 7 plus 4 root 3, which is the expression under our root. It therefore means I can use this to rewrite the entire equation as x equal to the root. So instead of 7 plus 4 root 3, I will replace it with 2 plus root 3 all that squared. So I will replace 7 plus 4 root 3 with this bracket. So I will have 2 plus root 3 all that squared. If you watch my previous video, I explained that the root and the square root, they cancel out. So this square root and the square, they cancel out from the law of indices. So that now your x will be just 2 plus root 3. And in mathematics, if we say x equal to 2 plus root 3, it means wherever we see x, we can replace it with 2 plus root 3. So we can replace it with this value. It therefore means that x plus 1 all over x will be equal to 2 plus root 3. I'm replacing 2 plus root 3 in the place of x, plus 1 all over 2 plus root 3. So the method of handling this question, of simplifying this expression, will just be to represent it as a single fraction. So it is for us to represent this as a single fraction. So I will therefore write this one as all over 1. So the highest common factor of these two guys of 1 and 2 plus root 3 will be 2 plus root 3. So 2 plus root 3 divided by 1 is 2 plus root 3 multiplied by the numerator will be 2 plus root 3 squared. Plus 2 plus root 3 divided by 2 plus root 3 is 1 multiplied by 1 will give me 1. All that on 2 plus root 3. So recall from above, we already saw that 2 plus root 3 all that squared is the same as this. So the expansion, we have already expanded 2 plus root 3 and it gives us this. So this expression now becomes 7 plus 4 root 3, that is in this place, plus 1, all that divided by 2 plus root 3. So 7 plus 1 gives us 8 plus 4 root 3, all that on 2 plus root 3. Now, we cannot add 8 to this because this one is a third. This one is not a third. In math, you can only add or subtract like terms. So we cannot add 8 to this. That is why I took this one and added to this 7 because 1 and 7 are like terms. So 1 can be added to 7 to give me 8. But you cannot add any of this to this value because this is a third. Now, if you look at this expression that we have, you discover that there's a third in the denominator. We do not leave a third in the denominator. In order for us to eliminate this third in the denominator of a fraction, we proceed by applying what we call the principle of rationalization of the denominator. What is the principle of rationalization of the denominator? It is to multiply both numerator and denominator by the conjugate of the denominator. The conjugate of this denominator is just for us to interchange the signs. So since the sign here is plus, the conjugate will be negative. So that this thing now will be written as 8 plus 4 root 3 all over 2 plus root 3 times 2 minus root 3 all over 2 minus root 3. This is still the same term because 2 minus root 3 can cancel itself. It's still the same thing. So what I am trying to do is just to rationalize this denominator. So for 2 plus root 3, the conjugate is 2 minus root 3, like I explained, that you just interchange the sign to obtain the conjugate. So if the sign is plus, the sign of the conjugate will be negative. If the sign is negative, the sign of the conjugate will be positive. So we proceed by, before I continue, I would like you to watch this video right up to the end. You should like, you should comment, and you should share. You may not be interested in mathematics, but you may have people who are interested in mathematics. You may have younger ones who are interested in mathematics. These concepts might help them in their exams. So you can share, and I'm going to be giving at the end of this video, I'm going to be giving a bonus challenge, which I want you guys to solve and post your answers in the comment section. So you post your answers in the comment section so that when my next video I'll be posting, we'll be able to know the correct answer. So that will just be an application exercise for us to handle at our spare time. And you post your answers in the comment section. Okay, so how do I expand this? So I will take 8 multiplied by 2, that gives me 16. 8 multiplied by this will give me negative 8 root 3. Now watch out. If you don't see any number in front of the third, it means the number that is actually there is 1. So the value in front of root 3 here is 1. So I am using 8 to multiply by 1. That is why I have negative 8 root 3. Plus 4 multiplied by 2 will give me 8 root 3. Because the 4 is multiplied, this 2 is multiplying by the value in front. 2 is just a number, 4 is also a number. So 2 multiplies the 4, which is 8 root 3. You cannot take these 2 and multiply inside these 3 because they are not the same. 2 is not a surd, but root 3 is a surd. That is why the 2 multiplies only by the 4. Then 4 multiplied by this will give us, like I said, the number in front, the value in front of my root 3 is 1. So 1 multiplied by 4 is 4. Then root 3 multiplied by root 3 is root 3 squared. All that over 2 multiplied by 2 is 4. 2 multiplied by negative root 3 will give us negative 2 root 3. Root 3 multiplied by 2 will give us positive 2 root 3. Root 3 multiplied by root 3 will give us negative root 3 squared. So we have, you see that negative 8 root 3 plus 8 root 3 cancel out. So this guy and these guys, they cancel out. So this term and this term, they cancel out. Because negative x plus x is 0. Negative y plus y is 0. So we have 16 root 3 squared. Like I said, the square and the root, they do what? They cancel out. So we'll be left with what? 3. 3 multiplied by negative 4 gives me negative 12. All over negative 2 root 3 plus 2 root 3, they also what? They also cancel out. So below here, I have 4 and the square and the square root, they cancel out. So here will be negative 3. So this is actually 16 minus 12 is 4 divided by 4 minus 3 is 1. So therefore, my x plus 1 all over x is actually 4. So that is the answer. So you can always apply these nested radicals correctly by following this principle. So now I will proceed by showing to us our bonus challenge. Our bonus challenge. So what is our bonus challenge? What is the bonus challenge? The bonus challenge will be for us, find the value bonus. Find the value of x if the root of x plus the root of 9x equal to 6. So find the value of x if the root of x plus the root of 9x equal to 6. So this is the bonus challenge. In your spare time, you just try to solve this question and find the value of x. In my next video, I'll be posting the solution to this nested radical. So post your solution, post your methods. I know that there are different methods of handling questions in mathematics. So you may have a method that you want to post. Post it, comment, share, and like. See you in my next video.